0200 hours on the digital tracking system of the destroyer USS Leon DG-58. What began as a standard patrol quickly shifts into a tense and unpredictable encounter. Without warning, the Russian frigate Admiral Gorshkov executes a sharp 90-degree turn. Moving at 30 knots, the warship cuts across the destroyer's bow, passing at a distance of under 100 yards. It is so close that the American crew can even feel the low-frequency vibration of the Russian engines. As collision alarms echo through the ship's corridors, the Gorshkov escalates the situation further. The doors of its vertical launch system slide open, revealing Zircon hypersonic missiles, a highly provocative display of readiness that has not been witnessed in these waters for decades. Inside the Combat Information Center, the tactical action officer remains composed and controlled, ordering the team to hold course, keep emissions low, and closely track the Russian fire control activity. It is the first time in 64 years, since the Cuban Missile Crisis of 1962, that a Russian naval vessel has so directly signaled offensive capability so close to Florida's strategic perimeter. For Washington, this represents one of the most serious maritime provocations in recent memory. 02:15 hours. While global attention remains fixed on the maneuvers of the Gorshkov, a second and far more subtle danger is operating in its shadow. Following 5 miles behind is the Seahorse, an aging single-hull Russian oil tanker carrying approximately 200,000 barrels of heavy crude. Far from an ordinary commercial vessel, it is treated as a high-risk environmental liability due to its outdated design, which is prohibited under modern maritime safety standards because of its vulnerability to catastrophic spills. From Moscow's perspective, this formation is part of a calculated strategic message. For months, tensions have escalated between Russia and NATO, with Western-supplied systems being used against targets deep within Russian territory. In response, the message being sent toward Washington is uncompromising. Pressure applied in Europe could have consequences reaching far into the Western Hemisphere. The strategy relies on the assumption that the U.S. Navy would hesitate to engage aggressively near the tanker, since any miscalculation could trigger a major ecological disaster. A breach in the vessel's hull could devastate marine ecosystems and severely damage Florida's tourism economy for years. At the same time, there is a media dimension to the operation, with expectations that any confrontation could be framed as aggression against civilian energy transport bound for Cuba. In response, the United States launches a classified operation known as Southern Spear, grounded in long-standing maritime policy in the region. Washington's objective is to prevent any scenario in which strategic naval assets operate freely in the Caribbean under environmental leverage. The mission focuses not only on halting the tanker's influence, but also on countering the escort vessel equipped with advanced missile systems that is operating alongside it. 03:30 hours. As the Russian formation approaches a critical and narrow maritime passage, the situation shifts once again, moving from visible maneuvering into the realm of covert electronic interference and signal disruption. Beneath the acoustic shield created by the heavy tankers and the constant churn of their propellers, several Russian-flagged trawler-type vessels, later identified as covert AGI collection platforms, quietly began deploying a formation of micro-UUVs into the frigid depths. These devices were designed to resemble local marine species in both shape and movement, allowing them to blend naturally into the underwater environment while carrying a highly specialized electronic payload. Once deployed, the UUVs descended and positioned themselves above key undersea fiber optic routes connecting the United States with South America. Their objective was not physical destruction of the cables. Instead, the systems activated powerful low-frequency transducers, flooding the surrounding waters with dense acoustic interference across the 10 Hz to 500 Hz range. This band was deliberately selected to overwhelm the sensitivity of the U.S. Navy's SOSUS hydrophone network, a vast seabed surveillance system capable of detecting submarine activity across extreme distances. By introducing this layer of acoustic white noise, the Russian systems created a localized underwater distortion field that severely degraded passive sonar performance. As a result, detection capability in the area dropped sharply, affecting platforms such as the USS Laboon and nearby submarines operating in coordinated defense patterns. With underwater awareness disrupted, Russian planners aimed to open a temporary corridor toward the U.S. coastline, allowing the Gorshkov to advance closer to Florida while simultaneously collecting high-value signals intelligence from coastal radar and communication systems. However, this approach carried a critical flaw. In modern networked naval warfare, any platform emitting structured interference becomes visible through pattern recognition systems. In attempting to mask their presence with noise, the source itself becomes easier to locate within an integrated detection grid, 0545 hours. As the formation crossed deeper into the coastal approach zone, the engagement shifted decisively. The USS Laboon activated its Advanced Electronic Warfare Suite, the AN/SLQ-32 V7 Surface Electronic Warfare Improvement Program Block 3 system. Far from a simple jamming tool, the system operates as a sophisticated electronic manipulation platform. Using DRFM-based techniques, it intercepts incoming radar signals, alters their phase and Doppler characteristics with extreme precision, and returns them to the sender in a modified form. On the Gorshkov, radar operators suddenly saw their tactical displays collapse into confusion. Instead of a single U.S. destroyer, multiple identical contact signatures appeared across the horizon, each behaving as a fully real, fast-approaching warship. This false environment created severe decision pressure on the Russian command team. In an attempt to break through the deception, they activated high-power fire control radar to regain a clear tracking solution. That decision triggered the next phase of the engagement. The U.S. system immediately detected the emissions and responded with a concentrated electronic countermeasure burst, directing high-intensity energy precisely back along the radar's operating frequency. The effect overwhelmed the Russian tracking system, disrupting its ability to maintain a stable lock and leaving its targeting picture effectively blinded in the electronic spectrum. The front-end receivers of the Gorshkov's fire control radar were suddenly pushed beyond their thermal and computational limits. Built-in protection systems engaged instantly, triggering emergency shutdowns to prevent permanent damage to the hardware. At the same moment, a ship-mounted directed infrared system on the American side swept across the frigate's bridge section. Although the beam could not physically penetrate the armored structure, it overwhelmed the vessel's external electro-optical sensors and backup camera systems, effectively saturating and disabling them. Within seconds, the Russian warship's external visual awareness was reduced to near zero, leaving it operationally disoriented and unable to reliably track its surroundings. By 0830 hours, with the Gorshkov effectively blinded and tactically compromised, the engagement transitioned into a deeper layer of conflict, focused entirely on information control. In a coordinated operation, NSA and US Cyber Command initiated a precise, non-destructive cyber intervention, targeting Russian-operated satellite relay infrastructure based in Cuba. Rather than cutting communication entirely, the objective was subtler: control the flow of information. Through a sophisticated interception process, U.S. systems gained access between the Russian command network and Moscow, allowing them to manipulate and redirect data without fully severing the link. At the same time, a synchronized digital reconstruction of the battlespace was built using P-8A Poseidon aircraft operating as airborne encrypted relay and sensing nodes. Once the system was in place, Russian navigation and tracking inputs began receiving carefully altered positioning data. To the Russian crews, their system showed a gradual and controlled withdrawal towards safer waters. In reality, the continuous small deviations in course guidance were steadily steering the warship into a contained operational zone, already surrounded by U.S. naval and Coast Guard assets forming a tightening perimeter. Back in Moscow, command analysts continued receiving what appeared to be stable telemetry from the fleet. Unbeknownst to them, their flagship was no longer operating under true situational awareness, but was instead functioning inside a fully constructed information environment shaped by external electronic manipulation. By 1100 hours, even as the warship had been effectively neutralized in the digital domain, a separate and immediate danger remained unresolved. The tanker trailing behind, the Seahorse, was still on a dangerous trajectory toward ecologically sensitive coastal waters. With communications degraded and external control lost, the civilian crew aboard the tanker shifted to a desperate course of action. They manually locked the vessel's steering system into a fixed heading aimed toward the Florida Keys Reef region and advanced the throttles to full power before abandoning the bridge and sealing themselves within the engine compartment. Their intent was clear: force a crisis severe enough to dictate the terms of any response. In response, an MH-60R Seahawk helicopter launched from the deck of the USS Leon, rapidly accelerating to maximum safe operating speed. It descended aggressively toward the tanker, maintaining an extremely low hover over the stern. The rotor wash churned the air into chaos, scattering smoke and spray across the deck and disrupting visibility across the vessel. Amid the turbulence, a U.S. Navy boarding team fast-roped onto the moving tanker. These operators were trained specifically for high-risk maritime interception scenarios, executing the insertion while the vessel continued forward at speed, setting the stage for the next phase of the confrontation. The boarding team consisted of elite tactical operators equipped with hydraulic breaching tools and specialized combat gear. Moving with the kind of precision that comes only from years of relentless preparation, they forced entry into the heavily reinforced bridge in under a minute. Inside, they found the helm system locked down and the crew refusing access from secured compartments below. There was no time for extended negotiation. Instead, the operators deployed portable override systems designed to interface directly with the ship's control circuitry, allowing them to take control of critical steering and propulsion functions at a hardware level. Working under extreme time pressure, the team systematically disabled propulsion controls and cut off fuel delivery to the main engines. Deep within the vessel, the massive diesel systems wound down, their power fading until the entire ship lost thrust. The 80,000-ton tanker began to slow, its forward motion gradually diminishing until it finally drifted to a controlled stop just over a mile from a protected coral reef zone. Rather than resorting to destructive force, which could have triggered an environmental catastrophe, the operation relied entirely on direct physical intervention and precision systems control. It was a clear demonstration that even in highly technological environments, outcomes often depend on human execution, discipline, and decision-making under pressure. By 1300 hours, the Russian naval group entered Havana under the impression of success. From their perspective, they had captured valuable electronic intelligence and achieved a strategic breakthrough. However, the data they had collected was not what it appeared to be. The radar and tracking signals recorded by the Gorshkov were artificially generated and embedded with deliberately constructed anomalies. Through advanced adversarial data manipulation techniques, the system had been designed to corrupt analytical models once processed and integrated into weapons development pipelines. When this compromised dataset was fed into missile guidance optimization systems, it introduced hidden errors and structural flaws into the software logic. As a result, systems relying on that data would become progressively unreliable over time. In reality, while the Russian side believed they had secured a strategic intelligence advantage, they had instead absorbed corrupted inputs that undermined the integrity of their own technological frameworks. The broader outcome was not measured in territory or ships, but in information dominance, where control over data ultimately shaped the effectiveness of advanced weapons systems.